All right, today we're going to look at 4 more examples of finding the solution to a given differential equation. And in every example, they're going to give us some initial condition that we can use either to find the plus c, or sometimes there's a plus or minus that we have to decide. First thing we're going to do is start with the actual differential equation. We need to separate it. We're only doing separable differential equations. So when we separate it, we get all the y's on the left and all the x's on the right. So I'm going to multiply by dx, and I'm going to divide by y to the third. Okay, now that I've separated everything, I can go ahead and do the integral on both sides. You'll notice that I did leave the negative on the outside. It's just a constant, so it can come out. And I do need to rewrite this as y to the power of -3. So I'm going to go ahead and do that right now. All right, now I can do the integral on both sides. On the left side, we add 1 to that power, so we get -2, and then divide by that new power, so we're dividing by -2. On the right side, we add 1 to the power, so we get x squared, and then divide by that new power. I'm going to multiply both sides by -2 because we have a -1/2 here and a -1/2 here. So if I multiply everything by -2, I'm going to get, and you might notice that I've called this C1, and I'm doing that because now I can change all of this for just a C. Remember, -2 times some constant is still just another constant. So this just makes things a little bit easier. So I'm going to trade all of this for a plus c. I'm going to do that right now. And you might notice that I'm putting the x squared plus c over 1. And the reason I'm doing that is because I want to have a fraction equal to a fraction. And so I can basically flip both fractions upside down. So I'm going to get y squared over 1 is equal to 1 over x squared plus c. And I can get rid of the divided by 1. I don't need that to be there. Again, I am solving for y, so I need to get rid of the squared. So I'm going to do the square root on both sides. On the left side, I have absolute value of y. And I can get rid of the absolute value if I put a plus or minus in front of the y. All right, and I can move this plus or minus over to the other side. Square root of 1 is just 1. And I want you to notice that when I plug in a +5, I'm getting a negative y value. This is a square root function, so that piece will always be positive. So the only way I can get a negative is if I choose the negative here. So I'm going to use this point to choose between the plus or the minus. I'm choosing the minus. And we're almost done. Now we just need to solve for the c over here. Again, we're going to use our point, which is 5, -1. So when x is 5, y is -1. We can plug that in. Because there's a negative on both sides, I'm going to multiply both sides by -1. Then I'm going to multiply both sides by the square root that we see on the bottom. Then I'm going to square both sides. And then I'm going to subtract 25 from both sides. So I'm basically done. This is my final answer right here. But my c value is -24. So I'm putting -24 right here. So here's our final answer. I'm going to put a box around it. This answer was sitting there the whole time. It's in the orange box. But I do want to talk about this component right here. So for a moment, I'm going to erase all the writing on the screen. So we can talk about why does it say that x has to be strictly greater than the square root of 24. That's the tricky part of this question here. If you look at the bottom of this fraction, we have the square root of x squared minus 24. Because x squared minus 24 is inside the square root, it must be greater than or equal to 0. And because it's on the bottom of the fraction, it actually cannot even equal 0. So we're going to say, well, x squared minus 24 must be strictly greater than 0. We can solve this. We add 24 to both sides. We can do the square root on both sides. So we're getting plus or minus x is strictly greater than the square root of 24. So that means either x is strictly greater than the square root of 24, or if we multiply both sides by the negative, we would get that x is strictly less than negative square root of 24. So we're getting two situations here. One of them is graphed over here on the right side. The other one is over here on the left side. Remember, this is a particular solution. We're not allowed to have both. So this is a very tricky example. You'll see that our point is over on the right side. So we want the one that says x is strictly greater than the square root of 24. We do not want this one over here on the left. I'm going to cross it off. So again, I'm going to erase everything here. I just want to point out that I think everyone can get this part here. Just have to be careful. Everyone can get that. But I think a lot of people would leave this out. This thing is what's making it tricky and difficult. I'm not sure that they would give you this kind on the AP test, where it requires a domain restriction. Most of the examples I've seen on the AP test just ask for the actual function, and most of them do not require this restriction over here, but you never know, so you always want to be prepared. All right, let's go to our next example. Okay, here we go. Find the solution to this differential equation. They give you the initial condition when x is 2, y is 0. So again, this is a separable differential equation. We can separate it. We want all the y's on the left and all the x's on the right. Okay, I divided both sides by e to the y, and I multiplied both sides by dx. Now I can do the integral on both sides. I do need to rewrite this as e to the negative y. Now we can do the integral on both sides. I'm going to put the plus c on the right side. For the integral on the left side, you do need to do a u substitution. Now I need to solve for the y, so I'm going to start by getting rid of this negative in the front right here. I'm going to multiply everything by -1. Now my y is stuck as a power, so I'm going to need to do ln of both sides so that I can bring that power down. On the left side, we have ln of e, which is going to cancel. You're just going to be left with -y. We still need to get rid of the negative, so I'm going to multiply both sides by -1. And now we're basically done, other than trying to solve for the plus c. So we got to solve for our c value. We're going to use our point for that. We have the point 2, 0. So when x is 2, y is 0, we can plug that in. Now this might be the only tricky part of this question. You have negative and then ln, but it's equal to 0. You can get rid of the negative pretty easily. You just multiply both sides by -1. So now we have ln of some number is going to equal 0. So the tricky part is that we need to know that ln of 1 is equal to 0. So the only way that this equation is going to be solved is if the inside stuff here is equal to 1. So we need to set that equal to 1. So the -16 plus the 8 is just going to be -8. And then minus c is equal to 1. We can subtract 1 from both sides. We can add c to both sides. So we get c is equal to -9. But this is a minus c, so it's going to be minus -9. And so that's how we're getting a plus 9 here for our c value. So that's pretty much it. This is our final answer. Let's put a box around it. And that's pretty much it for this example. Our answer is in that orange box. You can see the graph of it is above the orange box. The particular solution was 2, 0. You can see that point is right here, 2, 0. Now just real quickly, kind of as a review, there is one more way you could solve for this c value. You could just do e to the left side equals e to the right side. And you can see e to the 0 is going to give us 1. And e to the log base e will cancel. So you're just left with -16 plus 8 minus c. So we are getting the same thing. We're getting -8 minus c is equal to 1. That's what we already had. So I'm just showing you a different way that you could solve for that c value. All right, let's go to the next example. Okay, similar kind of thing, solve for the differential equation. They do give you the initial condition. So our first step is to separate this. We want to get the y's on the left and the x's on the right. We're going to multiply by y, and we're going to multiply by dx. Then we can do the integral right away. We'll put the plus c on the right side. I'm going to start by multiplying everything by 2. I have a 2c right here. So I'm going to call this one c1, so that 2 times c1 can just be replaced with a c. I'm going to erase that and just put a c. And we're still trying to solve for the y, and I have y squared, so I'm going to need to do the square root on both sides. The left side is going to give me absolute value of y. I can get rid of these absolute values if I put a plus or minus in front of it. And of course I can move the plus or minus over to the other side. I'm going to use my point to decide between the plus or minus. When I plug in an x value of 1, I need to get a y value that's negative. And since this square root is a function, that square root will always be positive. So the only way to get a negative is to choose the negative right here. There we go. And last step is just to solve for our plus c over here. If you have a point, we can plug it in. X is 1 and y is -5. We can multiply both sides by -1. We can square both sides. And we can subtract 19 from both sides. We're getting a c value of 6, so we have a plus 6 right here. And that's pretty much it. That's our final answer. You'll notice that we do have our initial condition right here. This point is the point 1, -5. I do want to point out that we have a vertical tangent line on the x-axis. So that's why we do not draw the top of this. Also, we would not have a function if we drew the top of it. So that's our final answer. Let's go ahead and put it in a box. There we go. Now, before we go to our last example, I just want to talk about the domain and range restrictions for our solution. Again, I think the AP test is only going to ask you for this equation here. I don't think they're going to ask you for the domain or range restrictions. Basically what we have is we have a hyperbola in this situation. There's a left side, there's a right side, but our point was 1, -5. So our point was approximately right here. And so we had to choose this piece of it, and we had to stop right here. So we put an open circle right there, because otherwise, if we continued on, we would not have a function. We can draw a vertical line. You can see the vertical line would intersect twice. So we wouldn't have a function if we drew the top of that. And I want you to notice we can also not include this part over here, because remember, a particular solution must be graphed on a single open interval. So we're not allowed to include this side of the hyperbola. So our answer is just this piece here, which is the bottom right side of this hyperbola over here. Now, if they did ask for the domain and range, how would you get it? Well, the y value you can see visually. It's pretty easy. The y has to be strictly less than 0. So I'm going to write that down over here. And for the x value, we can see that the x has to be strictly greater than, and then whatever this number is right here. So we need to find that x value. Let me get rid of this graph here at the bottom. And so basically we just need to find the 0 of this function, and that would be this spot right here. So we just really need the inside of this square root to equal 0. Of course, there's a lot of ways you can do this. You can even do this with the a, b, c, where the a is 1, the b is 18, and the c is 6. And plug it into the formula if you needed to. Okay, you might remember this from Algebra 1. We're getting two answers, -9 plus 5√3 and -9 minus 5√3. So this x value right here is going to be -9 plus 5√3. So there you go. If you had to give the domain and range restrictions, that's what it would be. Y would have to be strictly less than 0, and x would have to be strictly greater than -9 plus 5√3. Again, I seriously doubt they're going to ask you for those domain and range restrictions. I think your answer is just going to be what you see in that orange box. And if we go back a few pages, I also don't think they're going to even ask you for this domain restriction here. I think the answer that you would give is just here in this orange box. All right, let's do our very last example. Okay, again, they're asking us to find the solution to this differential equation right here, given this initial condition right here. So again, we need to separate it. We need to get the x's on the right side, so I'm going to multiply both sides by dx. And I need to get anything with a y over the left side, so I'm going to divide by y plus 3 to the power of 2. There we go. We're going to go ahead and do the integral of both sides. For this one right here, I need to rewrite it as a power of -2, so I'll move it up. And both of these are going to require u substitutions. So if you wanted, you could do a u substitution for this one, and maybe a v substitution for that one. Okay, there we go. I'm putting the plus c on the right side. You might notice that there's a negative on both sides, so we can multiply both sides by -1. We can write the left side as a fraction. It would be 1 over y plus 3. And we can put the right side over 1. So that way we have a fraction equal to a fraction. We can basically solve this by just flipping both fractions upside down. All right, let's move this up a little bit. If I flip both fractions upside down, I'm going to get this right here. And I really don't like this 1 over pi here, because you got this big fraction and you got another fraction there. So I'm going to multiply the top and the bottom by pi. So everything times pi. And this is going to cancel right here. Let's erase that. Now -c times pi is all going to be a constant. So what I could do is just call this c1 up here. So this would be -c1 times pi, which is just another constant. So I'm going to replace all of that with just a plus c. So all of this, let's erase it. Let's put a plus c for all that stuff. There we go. Again, I'm still trying to solve for y. I can get rid of this divided by 1. So I just need to subtract 3 from both sides to solve for y. And there we go. We're almost done. We just need to solve for the c and we will be done. All right, again, let's move this up a little bit. We're going to use our point to solve for the c. This is a 1/2 for the x and a -2 for the y. Okay, cosine of pi over 2 is going to give us 0. I can add 3 to both sides. That's going to give me 1 over here and pi over c here. And if I just multiply both sides by c, I'm going to get that c is equal to pi. So I'm pretty much done. I'm just going to put a pi right here, and then I'll be done. There we go. We're putting the pi right there in that position. So that'll be our final answer. Let's put a box around it. There we go. That's our last example. And there's nothing really weird happening here. There's no restrictions for the domain or the range. So that's pretty much it for our examples. And now it's just time to practice some of these. So we'll stop right here.